Video title: How do neural networks work? A deep dive into the architecture. Video description: In this video, we take a deep dive into the fascinating world of neural networks. We'll explore how they work, their architecture, and why understanding them is crucial in the field of artificial intelligence. Join us to discover the building blocks of AI and their importance in shaping our technological future. Welcome back to AI Simplified, where we break down how AI works, its uses, and the ethical considerations surrounding it. Today, we're diving deep into the world of neural networks. We'll explore how they work, their architecture, and why they're so important in artificial intelligence. Let's get started. What are neural networks? So what exactly are neural networks? Neural networks are a type of artificial intelligence that mimics the way the human brain works. They're made up of layers of nodes or neurons which process data in a way that's similar to how our brains process information. Example: imagine a neural network as a web of interconnected points, each one passing information to the next. This web allows the network to learn from data and make predictions. The architecture of neural networks. Let's take a closer look at the architecture of neural networks. Neural networks consist of three main layers: the input layer, hidden layers, and the output layer. Input layer. The input layer is where the neural network receives its data. Each node in this layer represents a feature or variable from the input data. For example, in an image recognition system, the input layer might receive pixel values from an image. Hidden layers. The hidden layers are where the magic happens. These layers process the input data by applying various transformations. Each node in a hidden layer takes input from the previous layer, processes it, and passes it on to the next layer. In our image recognition example, the hidden layers might detect edges, shapes, and other features in the image. Companies like Google and Facebook use neural networks with many hidden layers, known as deep learning, to improve their AI systems. Output layer. The output layer produces the final result of the network's processing. Each node in this layer represents a possible outcome or classification. One example: in our image recognition system, the output layer might classify the image as a cat, dog, or other object. How neural networks learn. But how do neural networks learn? They learn through a process called training. During training, the network adjusts the weights of the connections between nodes to minimize the difference between its predictions and the actual outcomes. Example: imagine teaching a child to recognize animals. At first, they might make mistakes, but with feedback and practice, they get better. Neural networks work in a similar way. Training involves feeding the network lots of data and using algorithms to adjust the weights. One common algorithm is backpropagation, which helps the network learn from its errors. Types of neural networks. There are different types of neural networks, each designed for specific tasks. Let's look at a few examples. Feed-forward neural networks. Feed-forward neural networks are the simplest type. Data moves in one direction from the input layer to the output layer without looping back. These networks are used for tasks like image and speech recognition. Convolutional neural networks, CNNs. CNNs are specialized for processing grid-like data, such as images. They use convolutional layers to detect patterns like edges and textures. CNNs are widely used in image recognition and computer vision tasks. Companies like NVIDIA and Tesla use CNNs for self-driving car technology. Recurrent neural networks, RNNs. RNNs are designed for sequential data, such as time series or text. They have connections that loop back, allowing them to retain information from previous steps. RNNs are used for tasks like language translation and speech recognition. Companies like OpenAI use RNNs in their language models. Applications of neural networks. Neural networks have a wide range of applications. Let's explore some of the most common ones. Image recognition. Neural networks can identify objects, people, and scenes in images. This technology is used in security systems, social media, and more. Facial recognition systems in smartphones use neural networks to unlock your device. Natural language processing, NLP. Neural networks can understand and generate human language. This is used in virtual assistants, chatbots, and translation services. One example: virtual assistants like Siri and Alexa use NLP to understand your voice commands. 2. Companies, Amazon and Google are leaders in NLP technology. Healthcare. Neural networks can analyze medical data to assist in diagnosing diseases, predicting patient outcomes, and personalizing treatments. AI can help doctors identify tumors in medical images more accurately. Companies like IBM Watson Health and DeepMind are using neural networks to advance healthcare. Finance. In finance, neural networks are used for fraud detection, risk assessment, and algorithmic trading. Banks use AI to detect unusual transactions that might indicate fraud. Financial institutions like JP Morgan Chase and MasterCard are using AI to improve their services. Entertainment. Neural networks can generate music, art, and even write stories. This technology is opening new possibilities for creativity. AI can compose music that sounds like it was written by a human composer. Startups like Amper Music and OpenAI are pushing the boundaries of AI-generated content. Why understanding neural networks is important. So why is it important to understand neural networks? First, they're a fundamental building block of modern AI. By understanding how they work, we can better appreciate the capabilities and limitations of AI systems. Second, as AI becomes more integrated into our lives, knowing how neural networks function can help us make informed decisions about their use and impact. Finally, understanding neural networks can inspire innovation. Whether you're an entrepreneur, a student, or just curious about technology, this knowledge can spark new ideas and opportunities. Ethical considerations. Of course, with great power comes great responsibility. There are important ethical considerations when it comes to neural networks. One concern is bias. If the data used to train a neural network is biased, the AI's decisions can also be biased. It's crucial to use diverse and representative data to minimize this risk. Another concern is transparency. Neural networks can be like black boxes, making decisions without clear explanations. It's important to develop methods for understanding and explaining AI decisions. Privacy is also a key issue. AI systems often use large amounts of data, and it's essential to protect individuals' privacy and ensure data is used ethically. Conclusion and call to action. In conclusion, neural networks are a powerful tool in the world of AI with the potential to transform many aspects of our lives. Understanding how they work is essential for appreciating their impact and navigating the ethical challenges they present. We hope this video has given you a better understanding of neural networks and their importance. If you found this video helpful, please give it a thumbs up. Subscribe to our channel and hit the notification bell so you don't miss any of our future content. And let us know in the comments what topics you'd like us to cover next. Thanks for watching.